So here's what I have on the test assembly. I anticipated problems with operating a single air cylinder with the 30 psi that we're going to perform the test with. And if I regulated the test pressure down from the operating pressure, then I had to either submerge the regulator, or I had to run 4 lines back and forth from a regulator somewhere remotely mounted, which I thought would cause problems at any distance at all, which, I'm thinking we're going to go up a few feet, so it would have been a problem. So what I tried to do was operate it with the same 30 psi. So we'll regulate the pressure coming into this valve down to 30 psi before it ever sees the cylinder. I'll have an airline, and forgive me, I'm not very good with SolidWorks. I'll have an airline coming from this valve over to the cylinder, and then also an airline that tees in and goes down into this rod, which injects it into the radiator. You can see the way I'm going to operate this. Again, I don't know how to stop this rubber and make it expand on in SolidWorks, but you can see that it's going to hit here, and then instead of retracting through the part, it would expand. And there's enough force here being developed with this toggle mechanism that 30 psi or even 10 or 15 psi will be enough to squeeze this sufficiently to stick it inside to really grip inside the radiator. So this is how I fit everything in there. Here's a timer. I stuck a timer inside of the cover because I want to ensure that nobody gets hurt. So basically that timer is going to, when somebody stops the test and flips the toggle forward, it will exhaust the air for a certain amount of time before this cylinder retracts. Well, really extends, before the cylinder extends and allows for the part to shoot out of there. So I know that we're going to have a certain volume, probably half a gallon of air at 30 psi. If I wanted to have one thumb operated button, it's kind of what we talked about. So I got a handle here in front of the button, and then there's a cover that goes over the whole thing to keep people's fingers out. All of this stuff is submersible, so it should work just fine. I anticipate just a single thumb operation. You stick it in there, you flip the switch, this would retract and expand, and then I have another, it's not a timer, but I have a method for injecting the test air after that has expanded. That's on the live side, we'll call it. On the dummy end, all we're going to need is an air cylinder. Now, I didn't model a handle on this. I think you can just grab the air cylinder. That's a 2-inch bore air cylinder. To give you some idea, it's a 1/2 inch stroke, but it's 3 inches long. So I figure a person's hand can go there. The switch is a little bit off center because I can't fit it next to the nose of the cylinder. But I basically want to build a box. I didn't put the front cover on, but once you have a front cover on there, same concept. This would go into the dummy end, flip a switch, that'll retract it and lock it in there. We can get really fancy and tie it together so that you know that this switch is flipped before the other side is actuated, but there's really no danger in the other end being open. So I didn't plan on any of that. This is the side that I'd like to start with because we can model our forces, make one of these urethane tips, find out how much pressure it's good for. Really see if it's safe and if it's something we want to pursue, and if it is, then we can go with the more complicated side, where I'm using a Destaco clamp to actuate the thing and inject the air. Let me know if this is something you like. Thank you.